Jenkins server with Terraform on AWS. So we're going to provision 3 servers in cloud, in AWS cloud, and then we'll configure one of those servers to be our Jenkins server. That's all we want to do in the next 1 hour. All right, so let me start the timer, and then our 1 hour starts to count now. Start. All right, guys. To just give you an overview for people who are completely new to this and don't know what we are trying to achieve. What we want to do is, let me just give you an overview. So in IT, you're looking at working, we call that collaboration, as a DevOps engineer with developers. All right? So it means that for a particular project, we have developers from across the world writing codes, maybe in Java programming language, and then contributing the codes to a central place. So this developer from India, this developer from China, from Nigeria, from US, they are all writing codes as employees of Uber. And they are contributing these codes to a central code repository. This central code repository would be something like GitHub. Okay, so they write these codes in Java programming language, for example, and then send these codes to a central place where the organization can have access to the codes that they have written. And it is these codes that will now be converted to the application, Uber, that will now be deployed to our operations in cloud. So to achieve this, first of all, we would create a place where all of these codes will be saved to. We'll create our GitHub account and also give access to these developers. These are developers. To this repository, this code repository, so that they can all contribute. So our job now, the project we are trying to execute is set up a framework, set up what you actually call CI/CD pipeline, to introduce that, so that we can pull these codes from this central repository and build the codes into application. This is the scenario this is the infrastructure we are trying to set up that will allow us take all of these codes that have been contributed centrally to the organization's GitHub account, build that code into application. After we have built it into application, we'll now go ahead to deploy this application into operation. So we have dev, we have ops. So together, we are looking at DevOps. All right. So as DevOps engineer for this project is very big, can take a whole 6 months to learn, but let's take it step by step. So as DevOps engineer for this project, the first thing we want to do is build a server called Jenkins server, from where we'll coordinate all of these activities to pull the codes, to build the codes, into application, from artifact to application, and then deploy all of, the singular application that is resulting from that build. We want to now deploy it to operation. So there's this central place from where we do all of that. All right? This central tool that we use to do this is called Jenkins. Amongst these two other tools that we'll be learning alongside Jenkins would be tools like Git, how to use Git, and so on and so forth. But now, let us focus on Jenkins. So how do we set up Jenkins server so that it can do this work? So the first thing to do is, if we were to do this manually, we go to cloud. Now we're using AWS as our cloud environment to achieve this. So if we were to do this manually, this is what we would do to set up a Jenkins server or any server for that matter. So we go to AWS. If we're using Azure or Google Cloud, we'll go to whatever cloud platform we are using, but in this case, we are using AWS. So I just logged into my AWS account. So here I'm going to set up a server. In AWS, servers are called EC2. So I'm just going to manually set up an EC2 server so that you see what we are trying to do using code. All right, so right now I do not have any server running. So instances running, 0. So I can just launch one just to demonstrate to you how servers are launched in cloud. So let's call it Jenkins server, for example. All right, what operating system are we going to run on this server? Let us run Ubuntu. So I take Ubuntu, which is represented by the AMI, this number, you can see that, AMI 04A8, all right? There's a reason I'm showing you that so that when we are building it from code, you see the relevance. All right. And then what kind of system are we using? Big system that will run 12 processors simultaneously on 96 gig of memory, or just small system for class demo. For this purpose, small system, just to show you how it works. For class demo, it's okay. So it doesn't cost so much. And then I'm going to take a key pair with time you learn how all of this works. And then let's just simplify it and say launch our instance. So this is what it takes to go into cloud to set up a server manually. So our instance, our server has been successfully launched, right? So if I go to instances now, where I saw 0 before as the number of instances running, I should see 1 instance running right now, and that is the instance. All right? An IP address by which I can address the instance has already been assigned, and so on and so forth. All right, so if I were to do this manually, instead of using infrastructure as code, this is it. The system is running now. All right, so let me delete this server that I just created now. So I go and show you how to not do this manually, but to do this automatically. It's called automation in IT. All right, let me quickly go here and say this instance, I don't need you anymore. Terminate. So that instance is now being terminated. All right, so while that instance is terminating, in order for us to work as IT professionals, we need to work from an environment that allows us to automate deployment of codes and applications, and also the provisioning of our infrastructure. Those environments are generally called IDE, Integrated Development Environment. And there are a number of applications that you can use for IDE. In my own case, I'll be using Visual Studio Code, VS Code. So I launch my VS Code, and this is my VS Code. All right, guys? Now, let us start this project. All right? To start this project, let me go and create a folder for this project. So I could do it from here. I could do it from the Windows environment I assume you are already used to. So let me quickly go to my Windows environment. I go to my desktop. I go to my lecture notes. You could create this anywhere, but just for logical arrangement purposes, I'm just going to create it inside the DevOps1 training that we are doing. All right, so let me create a new folder here so that you see how this is done. New folder, bear with me. New folder. Let's call this folder IG class. All right, so that's it. Now I need something in this folder. Let me take, that thing that I need is the key pair. The key pair is what allows me to be able to connect to a remote server. Because in this case, we are going to create a remote server in cloud, and we are going to access that remote server from our local system, my local laptop. So I copy this key pair, and then I put it inside this folder. All right, so I just do Control V. All right, guys, so I've created a folder for this new project. If this was Shell project or Chevron project or something like that, I will name it that accordingly, and then I make sure my key pair is there. All right, so that is that. So I come to my integrated development environment, my IDE, and I say open new folder so I can start this project. Open folder. The folder that we just created now, that's what I want to open. So back to lecture notes, 2024. This course is DevOps5, and I say this is the folder for that particular project. So I take that and I say select. All right, so we are ready now. So my project will be all of the DevOps tasks related to this project will be deployed inside this folder, IG class. All right, so the next thing I want to do now is to set up my codes that will deploy, that will go into cloud. First of all, let me quickly clear this. Let's refresh to confirm that we do not have instance anymore. The instance we created earlier on has been terminated, has been deleted. So right now I do not have any. Okay. So let me come back to my ID. Now I want to set up code that will go from here to cloud to set up my server. All right, we can use one of many options, but the option we want to use in this case is the most popular of all of the options available out there. It's called Terraform. So Terraform is the most popular form of implementing infrastructure. Infrastructure simply means you are setting up servers, you are setting up networks, you are setting up databases, you are setting up IAM in cloud. Whatever service or resources you are setting up in cloud, we call them all infrastructure. So infrastructure as code means rather than going there to do it manually like we did before, we want to write codes that will automate the process, go in there and do it for us. Okay, so if we go back here, actually, I'm going to show you the code that we are going to use to do this. Let me go, there are many codes, but let me take a more detailed code. So for infrastructure as code, let me go to Control F. For Terraform, I will use this code. So can you see this code? This is Terraform code. This could have been generated for you by ChatGPT, or you go to Terraform. Let's go there. So I can come. Before we go there, let me first of all run this code. So I'm going to take this code, which I already have here. So I copy the whole of this code. All right, Control C. And I put this code generated for me either from the documentation or from ChatGPT, or it's going to take a whole lot of time for me to write all of that from scratch. So there's no need to waste to reinvent the wheel. So I take that code and I come here and I create a new file. So I say new file. This file should be called main.terraform, main.tf. All right. And in this file, I'm going to paste the code that I just copied. All right. So this is the code. This is the Terraform code. How did I get this code? How come I just copied it and pasted it here? That will be a different topic that we'll learn under Terraform as a course. However, at the end of all of the writing of the code, whatever you are importing it from, this is what you have. And what is this code saying? This code is saying, go to AWS. I have the option of taking any provider that I want. But in this case, go to AWS. And in AWS, within the region, US East 1, create for me EC2. How many EC2s? Maybe I say 3. I put 3 there, count. 3. So create 3 servers for me using the key pair, the itan.key pair, which I already created in cloud, right? And then you saw there are many types of instances that we could take from. In this case, rather than taking T2 micro, I'm using the instance type, T2 medium, and so on and so forth. And when you are done creating that server in cloud, give me the IP address, the public IP address by which I can access that server. That's what this code is saying. So this is Terraform code. All right, so I save this code, Control S. All right. Now let's go to a terminal. So we'll come here and say, create a terminal where I will use my knowledge of Linux to begin to enter the appropriate commands that will do this work for me. All right. So I could do this from PowerShell, or I can come here and I say, do this from any of the terminals. People will go git bash or use IntelliJ, but for us as DevOps engineers, we are most comfortable using Ubuntu because it's more like the most globally available one that most employers would need it. All right, so I take the terminal for WSL, which is Ubuntu. So the next thing I want to do now is run this code so that it goes into cloud and deploy and provision that server for me. So to do that, I am going to run this command. So let me, okay, don't worry. It's somewhere in the node, but I can just do it right away. So we're going to say Terraform initialize. So it's called Terraform init, all right? Which means the code that I have there, in fact, initialize Terraform for this project. So Terraform init is the first command, and that's a common interview question. The interview will ask you, you say you're a Terraform person, what are the 5 most common commands in Terraform? Terraform init will definitely be number 1. All right? So that's initializing, setting up the connection between our ID environment and our cloud environment. Let me see if I can show you that in the notes. You go back home. This is, yeah. So these are the most common 5 commands. Terraform init. And then the next command we want to run, just by way of getting used to how the commands work, is Terraform validate, after Terraform init has initialized Terraform. That is still initializing, so let's patiently wait for that to complete. All right, so Terraform init and then Terraform validate. Okay, so that is done. So if we say Terraform validate, it's going to look at the code that we have here. What's the name of our code? Main.tf. It will look at the code, check the code, and validate the code. That, oh, the code is good. I'll be able to execute it for you if you want to go ahead and execute it. Or no, this code is not valid. So it's going to look at the code and understand that, oh, what you want me to do is connect with AWS, and then once I get there, I create an instance of type T2 medium, and then I use this, okay, it looks at all of that, and then I leave all of the ports open so that I'm able to go in and come out at any time. Is that what you need me to do? Okay, fine. So yes, this code is valid. That's the answer we're expecting now. Once it says the code is valid, then we are ready to take the next. But if it says, no, I do not understand the code, there's error, then we look at the code and fix whatever error there is so that we can move on. So in this case, it says the configuration is valid. All right. So the next command, not compulsory, but just by way of learning how Terraform works, is to say Terraform plan. Terraform plan, let's do that. If we say Terraform plan, what does that do for us? So this is telling us if Terraform will tell us if we decide to go ahead and execute this code, this is what I will create for you. This is the plan. I will do this, I will do this, I will create this, and so on and so forth. So Terraform plan will give us the list of resources that will be created for us in cloud when we run this code. All right, so we'll just give a couple of seconds more for that to complete so that it shows us the list of resources it will create. And then once we are happy with all of that, there is nothing to change, everything is good, then we'll now go ahead and execute the code by entering the command terraform apply. Terraform apply. And then once we are done with all of our infrastructure, we have completed this project, we don't want the infrastructure anymore. Maybe altogether we created like 75 different resources in cloud for this project. We want to destroy them all, we want to terminate them, we want to delete everything. We'll just run the command terraform destroy. By the end of this project, after everything has worked according to our plan, then we're going to run terraform destroy. In the time being, let's see. Yes, so this one is ready, telling us that if we go ahead to execute this plan, it will create 5 resources for us. It will not change anything in our existing resources. In any case, we do not have any one, and it will not destroy, it will not terminate anything. So do we want to go ahead so that this code will create all of these 7 resources? And by the way, you'll be wondering, but we are creating 3 servers. How come it's talking about 7 resources? So in addition to these 3 servers we are creating, it's going to create other resources. For example, the security group for the server, the public IP address for each server, and so on and so forth. All right. So if we now go ahead and say, yeah, we like what we are seeing, go ahead and execute this. We are going to say terraform apply. All right. So terraform apply is the command that will ultimately deploy this code. By deployment of this code, what do we expect to have? We expect Terraform to connect to our AWS account and set up all of those 7 resources that it said it will do for us right here. All right, so let's just wait a couple of minutes for this to happen. So this is what we mean when we say to automate the provisioning of infrastructure in cloud. Right? So for this, we do not need to even come to the graphic user. The only reason I'm here is for me to be showing you that what we are doing here, there, is actually executing here. Because for some of you, you may not have even seen cloud before. Right? In operations, we would have done this so many times. They would not even need to give us access to this graphic user environment of cloud called console. This environment is called console. Compared to this environment where you don't see graphics, we don't use mouse, but we use keyboard to write command. This is called command line interface or your terminal. All right? So it says, I'm going to create all of this for you. Do you want it? I'll say yes. All right? So yes will now finally execute the plan. Earlier on, it told us theoretically that this is what it will do, but with this, they are now actually being deployed. Of course, we expect that will take a couple of minutes. So it's deploying, creating our AWS security group, creating AWS instance 1, instance 2, instance 3, and now it's creating a module EC22 instance, and so on and so forth. All right. So someday, as DevOps engineer, you'll be able to work fully from this IDE environment, and you will not need to come into the graphic user environment to do anything. It is at that point that you say, I am a DevOps engineer. I'm looking for DevOps role for 120, 130, 150K kind of work, depending on how much. Anyway, so the job is done, and this is the output, because we said in the code that once the job is done, it should give us the public IP addresses of all of the instances created. So here, it has given us the public IP addresses. And shortly, you will see why we need the public IP address. So let me save those public IP addresses in Notepad. Let me save them. So 3 servers, 3 instances have been created for us, and these are the public IP addresses of the instance. All right. So just by the way, because you are still babies, I assume in this part of IT. Now, let me quickly go to crowd and prove to you and show to you that those resources, those servers were actually created. So if I come here and I refresh, you see that just like we said, they were created. 1, 2, 3, 4, 5. I think I saw something about that code. Let me look at this code. I just copied them. I think I doubled some. But it's all good. It's part of the learning. All right. So here we said create instances and then T2 medium using this key pair and using that security group, fine. And then the provider will be AWS and create them in the region called US East, fine. And allow all the ports, don't block anything, fine. All right. And here we are saying T2 medium again, keep here. We are repeating what we have here. We are repeating that here. So there is duplicate in our codes. Our codes are duplicated. All right. And then we are saying do 3 of that. So I'll have to check this code and make sure that if I want 3 servers, I am creating only 3 servers. So in this case, I have repeated mistakenly actually, but it's all good. So I'm going to remove one part of that code instead of repeating what I have earlier. So for that reason, what did it do for us? It's called garbage in, garbage out. According to what I asked it to create, whether intentionally or mistakenly, it has created how many? So right now we have 7 servers, out of which 1 has been terminated. So we have 6 active servers. All right, in operation, this is not allowed because the code should do 3, and then you are having 6. So my mistake, I'll correct the code. But let's go on. So this has shown you that you have successfully used infrastructure as code to automate the deployment of infrastructure in cloud. Awesome. So let's look at the project again. What I was started to do. So the project says, provision servers using infrastructure as code on AWS. We just did that. Provision 3 servers in AWS using Terraform as your infrastructure as code. We just completed that. Now, configure one of the servers to become your Jenkins server. All right? So this project will be executed in our IDE environment, in which case we are using VS Code, and then without access to AWS console. However, I'm still showing you access to AWS console so that you just see, oh, it's actually working, it's actually working. All right, so the next thing we want to do now is configure one of the servers to become our Jenkins server so that it can play the role that we explained here earlier on of taking the codes from our GitHub, building the code into artifacts, into application, and ultimately deploying that application into operation. All right, so let's go. So to do that, we are going to SSH. SSH is how we stay on our laptop, terminal, on our IDE terminal here, right here, and be able to configure what is not local to our laptop, but what is this server that has been provisioned in cloud. There are 2 different environments, right? So we have cloud, we have our IDE environment within our own laptop. But we want to be able to configure what we have, the server that we have in cloud from here. So that concept of connecting to this server in cloud, which is remote to this our local server, is called SSH. I mean, it's called a remote connection, and it is SSH terminal that we used to do that. So now let us SSH into one of these servers. This is how to access it. All right, guys. So to SSH, I'm going to use this command. I'm going to say, using the key pair, the item dot, let me just copy it from here. If we do ls minus l, what I'm doing here now is I'm using Linux commands to make things work. This is why we need to learn Linux in order for us to become DevOps engineer. So this is the key pair. So I take that key pair, Control C. So just take key pair as the key that you need to open a padlock. That's the meaning of key pair. All right. So we'll take that key and then we'll put it here and we'll say, using this key, we'll say SSH using this key minus I into this server that we created and use Ubuntu at. So this is the command. Again, you may not remember this command. I mean, you may not know this command often. So you can just ask ChatGPT or copy it. Copy it from somewhere where you already have it. All right. So this is our code. This is the code I should have used. We just run that. Now, what we want to do is install Jenkins, like we said. So in order to remotely connect to this server, we go to PowerShell and then we run these commands. All right. I just happen to have assembled all of the commands in a central place for my own use. All of these commands are available here, there, through AI, and so on. They are available in documentations all over the internet. All right. So for every tool that is released in the market, there is a documentation that comes with it telling you what command to run where. All right, let me just go on so I don't take so much of your time. So I go to PowerShell and those commands that I copied, I run them. And now I see the reason I went to that note was to show you that this command that I just created earlier on is already here. So look at the command here. So I say SSH minus I using this key as Ubuntu into that server. So in this case, the IP address is different. So this is what I'm going to use in this case. Control C, and then I'll come to my terminal and I'll say, I'll enter that. Are you sure you want to SSH remotely into this server? I'll say yes. Awesome, it has been completed. Now, earlier on, it was showing me the prompt. It was showing me a different prompt. All right? All right, PLC user, and so on. But now it's showing me Ubuntu at this IP address. So even though I'm working from here, all of the commands I'll be entering now will be going into the remote server with this private IP address. So I successfully SSH'd into this server in cloud. All right, guys. So now we are now working in the cloud server. So if we want, we can rename this terminal to say this is our cloud server or this is our Jenkins, whatever you want to call it. You may call it, because you are going to have many terminals at the end of the day, maybe 7, 5, depending on how many servers you are working on simultaneously. All right, so now that we are successfully connected to this brand new empty server that we just created, let us start to configure it now to do the job that we explained earlier on. So to configure it, the first thing we want to do for this server, since it will be building Java code, is to install Java. To install Java on this server, the command is sudo apt update and then sudo apt install Java. This is the command. All right. So if we take that command, Control C, and we say prepare this environment for Java operation, and then we'll put it there. So Java, because this is the programming language, otherwise called the software development kit that we have agreed, the developers, based on the policy and the system analysis of this project, we have all agreed that the best programming language to use to develop this application and maintain this application to meet the specific customer requirement is Java. All right, so that's why we're using Java. If it was Python, then we'll be installing Python right now. If it was Node.js instead of Java, we'll be installing Node.js, and so on and so forth. And by the way, Java is one of the most popular programming languages for developing enterprise-level applications. So we'll rather talk about Java where we can. All right, guys, so Java is now installed. Every time you install a program, a tool or something, and you want to find out, is it actually installed? Is it there? The command is Java, in this case, ---- version. And if it tells you, yes, I can see that Java is installed, and it's installed, that is the version, and it's installed the Java runtime environment is installed, and so on. So that confirms that we just successfully installed Java. All right, so now that we have installed Java, remember we talked about build, that we need to build these codes into actually artifact first before application. So we need a different tool. It is not the same Java that we use as the programming language that we use to build. In the case of Java, we need a tool called Maven to help us build Java codes into Java artifacts. So we need to install Maven. So guys, let's go ahead and install Maven. To install Maven, we are going to use this command, right? We are going to say, go to this website, which is Maven documentation, and download the Maven. All of these are Linux commands. If we do not know Linux, then we will not be able to use this command. They are Linux commands, all right? And then we're going to say, after you have downloaded the Maven, unpack it from the carton. It's called extraction. We extract it. And once you have extracted the Maven application, put it in the directory where Java and Jenkins would always look for it. Create a room for itself and put it in the room. And then once you have done that, and the raw file is in the room, you may now install Maven. Right? So that's the meaning of these commands that I've highlighted. So let's copy all of that, Control-C, and say, do exactly that. So we'll put the command here, Control-V. So to do exactly what we have just enumerated. Go there, download the Maven files, and then blah, 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 and then ultimately install Maven. That was fast. Are you sure you installed Maven? Let's find out. The command to find out if Maven is not installed is Maven ---- And it says, yes, Maven is now installed. And Maven is installed in this directory, and this is the version of Maven installed. Oh, beautiful. All right, guys, we are doing great. So we have set up a server. We have installed the dependencies for Jenkins. And now that Jenkins has all of the prerequisites to work with, we may now finally install Jenkins. How do we install Jenkins? The command, okay, for the first time, I'm going to take you into a sample documentation so that it's not a matter of, so that you just say where we got all of these commands from. So like we said, every tool, every application comes with a manual, a documentation of how to use this tool. Right? In the case of Jenkins, we go to the documentation, Control-C, and then I take you into Jenkins. Where is Jenkins? Control-V. All right? So this is Jenkins documentation. All right? Long-term support release. So it says to install Jenkins on your Ubuntu server, just copy this command. All right? So this is the command. So we just copy that, click here, copy, and then we'll come back to our environment here, all right? And then we'll put all of that there. Are you sure you want to continue to install Jenkins? That's what it's asking us. We say yes. Yes or no? Yes. So Jenkins is now being installed. So as a DevOps engineer, we have set up our Jenkins server, which is basically for a fresh project, for a brand new project. So the interview asks you, oh, DevOps engineer, can you share projects with me that you have executed? And you say, yes, we have executed multiple projects. One of them is that I was part of the team that set up the infrastructure for a brand new project, all the way from Git management, setting up Jenkins servers, and building the CI/CD. CI means continuous integration. Let's not go into it. So now Jenkins is set up. Let's find out. Jenkins minus version tells us that Jenkins is now set up. Oh, beautiful, beautiful, beautiful. Everything we have done in 40 minutes now or less could take, in a typical classroom environment, could take you 2 weeks to learn, or maybe even more. But this is fast tracked because we just want you to see the end result of the thing. All right, so Jenkins is ready now. Now, let us go into this Jenkins server that we just created and start to use it for the purpose we described at the very beginning for this purpose. So to go into our Jenkins server, we need the IP address of our Jenkins server. What's the IP address of this server that we just created? The IP address of this server is this. So we'll take it, Control C, and then we'll go to our browser. We'll go to our browser and we'll say Control V. Come into this browser through the port 8080. That is how to go into Jenkins. Access it through the port 8080. And then we'll say Enter. All right, guys, so this is Jenkins. All right, so introducing us to Jenkins dashboard, it says, oh, beautiful. I'll let you in only if you have the password to this Jenkins server. What is the password? Oh, you don't know it, don't worry. I have it for you. This is the place. Go to the server, go to this room, knock, and then you'll find the password there. Get the password, come back here and put it in here. Then I will let you into Jenkins. You say, oh, thank you. So we'll copy that URL. We return to our Jenkins server. All right. So what we saw earlier on was just the dashboard, but this is the real place where everything is. So we say, they say this is where this is. All right. So that is the name of the file. This is Linux. Hopefully you understand how this works. Okay. So I'm going to say sudo cat, which means display the content of this file, which you would find inside this directory, which is in Jenkins and so on and so forth. Show me the content. If you press enter, it tells you this is the content of that file. Oh, you say, oh, beautiful. So you take the content, Control C, and then you rush back to the dashboard and say, I have the key now. I have the key now. Open the door for me. You pull the key there, and then you press enter. It says welcome. Now you customize your Jenkins server. All right. So what you want to do is install the common plugins that Jenkins needs to do its job as the integrator, the central tool for coordinating all of your DevOps activities. All of your development activities, all of your operations activities can be central. Maybe not all, but at least most of them can be centralized, operated from a central place. And that central place is Jenkins. All right, so your Jenkins is now being prepared. And then it will ask you, all right, who set up the user account for the administrator? Here you may just say admin. I'll just say admin, admin. And then the organization's email address will be my full name, maybe the item, and then my email address, the item. All right, so I say that is the administrator's account, and it's telling me, oh, fine, that is fine. Every time you want to access Jenkins file, this is the URL, exactly what we typed earlier. So this is what I got. If I want, I can say save that and then complete. All right, guys, we are now ready to start using Jenkins. If we say start using Jenkins for that role, it will bring us properly into Jenkins dashboard. All right, so this is where we'll stop today. And then I can take questions just to make sure, just to measure how much you understand from what we're doing. So with this one, we have now completed the process of setting up our Jenkins server. Was that what the project said we should do? So the project says deploy, no, not this one. Last project. Provision a Jenkins server with Terraform on AWS cloud. All right. So provision 3 servers in AWS using Terraform infrastructure as code. We did that. And configure one of the server to function as Jenkins server. We just completed that. Right. This project will be executed from the IDE environment, which in our case is VS Code, Visual Studio Code environment. And you will not need to go into AWS console to do anything.